the mole. Okay? You've seen Austin Powers. You can chuckle every time I say mole. Okay? It's funny. All right. We need to understand what the mole is as our kind of primary key point here. Okay? A mole is a unit for measuring the amount of something in terms of number of particles. Okay? So we could measure the amount of a chemical in grams, we could measure it in liters, okay? But sometimes it's helpful or useful to know at least an approximate number of particles. Obviously, we'll never be exact on that because atoms and molecules are exceptionally small, but we can get pretty darn close, okay, when we're talking about calculating the actual number of particles in a sample. Okay? So the purpose of the mole is to have a unit for chemistry that communicates the amount of particles of a material. Okay? Understand the relationship between moles mass and molar mass. That's going to be the mole equation. Okay? It's going to be a little bit of math, but it's really easy math. Okay? And then use the mole equation to solve problems. Okay? It's a simple 3-variable formula that you'll have no problem manipulating. Okay? So, like I said, we can express the amount of a substance in grams or moles or liters or whatever it is, okay? But we cannot possibly count all of the particles in a sample, right? Like, even if you could see atoms, it would be an unfathomable number of particles in even the smallest amount of something, okay? I wouldn't want to be sitting there with a pair of tweezers and magnifiers and going, 152,285, 152,286. What? Damn it. 1, 2. Like you wouldn't do that. Okay, it would take you your whole lifetime to count the amount of particles in even like a handful of sugar. Okay, we can't do that. So we use the mole as a representative unit. Okay, the mole always represents the same number of particles, just like something else we use all the time. I have a dozen eggs. How many eggs do I have?
12.
Okay, a mole works just like that, except it's not 12. It's 6.02 times 10 to the 23. It's a lot. You can't write a lot. That's not a valid answer, but that's a lot. Okay, that's 602 with 21 zeros behind it. Okay, it's a lot. It's a really big number. Okay, but if I have a mole of something, that's how many of it I have. Okay, just like a dozen. Doesn't matter if it's eggs, cookies, donuts. Okay, it's always 12. Okay, a dozen is always 12. A mole is always that number. Now that means that if I have 1 mole of hydrogen and I have 1 mole of lead, one of them is going to be heavier. Okay? I have the same number of particles, but lead atoms are bigger and heavier. Okay? And so there's going to be more mass there, even though I have the same number of particles. And it's no different if we're talking a dozen eggs and a dozen donuts. A dozen eggs is heavier than a dozen donuts are. Okay? It's the same number of particles, okay, or objects, but it's obviously going to have different masses. That's where the mole equation comes in, okay, and where the math is going to play a role. Okay, so this number here is Avogadro's number, and it is not a randomly selected number. It seems that way, but it's not. Okay, this number was actually arrived at through a lot of experimentation. Okay, Avogadro knew that chemistry needed some kind of unit that it could use to represent huge numbers of particles. So what he did is he took the simplest element, hydrogen, and he said, I'm going to figure out how many of the simplest particle there are in 1 gram. Okay, so he took 1 gram of hydrogen, and knowing, because hydrogen is a very simple atom, that it only had 1 proton, 1 neutron, and 1 electron, and the masses of those particles were at least approximately known, he figured out how many particles there would be in 1 gram, and made that his number. Okay, then that number applied to everything else. So when you look at your periodic table, you can see that there's these numbers here, atomic masses. Okay, the atomic mass of hydrogen is very close to 1 gram. Okay, 1.00794 grams per mole. So if I have 6.02 times 10 to the 23 atoms of hydrogen, it'll have a mass of just over 1 gram. Okay? If I have 6.02 times 10 to the 23 atoms of lithium, it'll have a mass of 6.941 grams, because lithium atoms are bigger. Okay? Everyone kind of follow me there? All right, so that's what the mole does. It represents a fixed number of something, okay? In this case, 6.02 times 10 to the 23. Okay. All right. Everybody okay with that idea? That's what the mole is. Okay. All right. Now, the mass of 1 mole of a substance, if it's an element, can be read directly off the periodic table. It's that element's atomic or molar mass. If I want to figure out the molar mass of a compound, what do I do?
You add them together, the mass of the both elements.
Yeah, I add together the mass of all the particles in that compound. So, if I was doing this for water, for example, in a molecule of water, there are how many hydrogen atoms? Okay. Okay, so hydrogen, 1.01, there's 2 of them, so I multiply it by 2, plus 1 oxygen. Okay, if I have 6.02 times 10 to the 23 molecules of water, or 1 mole of water, it will have a mass of 18.02 grams per mole. Okay? Everybody with me on how I calculated that? Okay, so what I did is I saw what was in this compound, hydrogen and oxygen. I looked up what's the mass for hydrogen from my periodic table, 1.01 grams per mole. Since there are 2 hydrogens, I multiplied it by 2. Okay, then I looked up the number for oxygen, 16. There's only 1 oxygen, 16. Add them together, I've got the molar mass of that molecule. Okay? So it's not difficult, right? You just got to look it up off the periodic table and add them together. Okay? It only gets a little bit tricky if you start getting polyatomic ions and brackets, and then you're having to figure out how much of everything there is, like in, say, that way. Okay? It's still the same process. Okay? I still look up all of the stuff that's in there. How many magnesium are there in this compound? 1. Okay, so that's 24.31. Okay? And how many manganese are there? 2. Okay, I don't remember what manganese is. 54.94. Times 2, because there's 2 of them. Okay? How many oxygen are there? 8. Plus 16 times 8. Plug it in my calculator, and I got the mass of 6.02 times 10 to the 23 molecules of manganese per manganate. Or magnesium per manganate, sorry. Okay.
So the unit for it is always like grams per mole?
If I'm calculating, yes, just like if I'm doing this from the periodic table, yes, this will be the molar mass, grams per mole, the mass of 1 mole. Okay? If I'm doing other calculations, then it might be in grams or moles when I get to the mole equation. Okay? Everybody all right with that idea? Okay, I want you to calculate the molar masses of these 5 things. I'll give you a few minutes to get ahead of me, and then we'll walk through it together. They go from easy to a little less easy. All right, so for our first one, we got sodium chloride. How many sodium are there? 1. Okay, so 22.99. Okay, and there's how many chlorine? 1. 35.45. All right, so what are we looking at here? 59. Sorry, I forgot to start my calculator before we got going on this. Hey, by the way, I told you guys about calculators yesterday, right? Yep. Okay, make sure you got one going forward for this. Come on. Okay, so 22.99 plus 35.45. We're looking at 58.44 grams per mole. Okay, questions on the first one? Okay. For number 2, we've got iron with bromine. Okay, so iron's 55.85. Yeah. Okay. And there's only one iron, and then there's the bromines, what, 79.9? Times 3. Okay, we punch that into our calculator, so 55.85 plus 79.9 times 3, 295.55 grams per mole. Listen.
Would the charge of the iron affect its weight? Technically has less electrons?
No, it wouldn't in a compound because that electron is still here, right? Like it's just being transferred to the bromine. If I was looking at an ion, there would be a ever so slight difference because the mass of an electron is 9.11 times 10 to the minus 31 kilograms. It's really small. Yeah. And all right. Third one. So I've got how many phosphorus here? 2. And where's phosphorus? 30.97. Okay. 30.97 times 2 plus 16 times 5 because there are 5 oxygens there. All right, 141.94. Grams per mole. How many people have done 4 and 5? I'm going to give you a couple more minutes to finish 4 and 5, and then we'll look at those. All right, let's look at the last 2 here. So for ammonium sulfates, okay, and as we were saying, if we've got a polyatomic ion, we've got to do this, and then we've got to do any molecule atom by atom, okay, or element by element, right? So in this compound, there are how many nitrogens? 2, right? So we got 14.01 times 2, plus how many hydrogens are there? 8. So that's going to be 8.08, 1.01 times 8. Everyone okay if I shortcut that one? Okay. All right, and then how many sulfur? Just 1, okay? 32.06 on yours? 0.7 on yours, okay. And then how many oxygens? 4. Okay, so we got 16 times 4. All right, so 28.02 plus 8.08 plus 32.07 plus 16 times 4. 132.17 grams per mole. Okay, questions on that one? All right, so it's just a matter of one element at a time for any of these types of compounds. All right, then we've got scandium carbonate. So we've got 2 scandiums, that's 44.96 times 2. Plus, how many carbons? 3. So 12.01 times 3. And there are how many oxygens? 9. Okay, 269.95. Okay, everybody all right with how to calculate molar mass? Okay, molar mass calculations are one of the parts of doing a mole equation calculation. Okay, when we get to the mole equation, this is the mole equation. N, which is number of moles, equals mass in grams divided by molar mass. Okay, so this is the thing we just learned how to calculate right here. Okay, it's part of the mole equation. Okay, questions on this? Okay, so when we're looking at a chemical reaction and it's all balanced for us, there's a number of different ways that it can be interpreted. Okay? It can be interpreted literally. 1 molecule of nitrogen reacts with 3 molecules of hydrogen to produce 2 molecules of nitrogen trihydride. It could be interpreted literally like that. Would I even notice that reaction happening?
No.
No. Okay, 1 molecule of this, 1 molecule of that makes 2 molecules of this. No chance. Okay, that is such an incredibly small amount of stuff that nobody would notice it. Okay, but what we more often interpret this to mean is 1 mole of nitrogen gas plus 3 moles of hydrogen gas gives us 2 moles of nitrogen trihydride. That's a number I would notice. Okay, because now we're talking about 28 grams of this stuff. Okay, we're talking about 6.06 grams of this stuff. Okay, and I don't know what this would be, but more grams. Okay, this plus this, it would be 34.06 grams of that stuff. Okay, how did I know that? No, I'm not. I won't claim to be. I added them, right, because law of conservation of mass, right? The whole reason we balance chemical reactions so we don't create or destroy matter. Whatever the mass of my reactants is, my products have to have the same mass or I've created matter or destroyed matter. Okay? Same mass on both sides. That's called stoichiometry. You won't get to that until Chem 20. Day 1, Chem 20, but yeah, Chem 20. All right? All right, so that's just the different ways that we can interpret a balanced chemical reaction. Okay? It's basically ratios, right? It's 1 mole to 3 moles makes 2 moles, okay, and so on. All right, so that's what we just went over. We could look at it as particles. That's Avogadro. Kind of looks like a mole. Yeah, you know, kind of got like the sunken eyes and it's kind of like a mole. So we talked about how it could be looked at as from particles, as moles, okay, or even mass if we wanted to, okay. That's why we put those coefficients in there when we're balancing a chemical equation, is to make sure that we've got the same number of moles or mass or whatever on both sides of the chemical reaction. Okay. Now, the mole equation looks like this. N equals little m over big M. Because, you know, chemists have to be difficult. There are 26 letters in the English language, and we use the same one twice in a 3-variable formula. And the only other letter we used is the one that sounds like the letter we used twice. N equals M over M. Okay? No one accuse chemists of being creative. All right? So, here's what we have to remember, okay? N is the number of moles. So this equation, as it's set up right now, is set up to calculate the number of moles. We calculate the number of moles by dividing our mass in grams by the molar mass, which is the mass of 1 mole. So if I take the mass I have, divide by the mass of 1 mole, that will tell me how many moles I have. Everyone follow my logic there? Okay? So that's the way that equation sets up. You will have to solve for number of moles. You will also have to solve for mass, little m, which will involve algebra. Okay? You will have to manipulate this equation to solve for little m without the use of a triangle. Because triangles suck, and I hate them. And I hate everyone who teaches you to do algebra using one. There's a lot of hatred. Okay? It makes me very angry. Now, here's why you can't use triangles, guys, to do algebra. Sure, a triangle works fine to manipulate a simple 3-variable formula. This is one of 2 3-variable formulas you will use in this course. Every other formula has more than 3 variables, and thus a triangle will not work to manipulate it. So you got to learn how to do algebra sooner or later. Now, it's both of those times. It's sooner and later. Right now, you have to learn how to do algebra and stop using a damn triangle to do your math for you. Okay? The reason I'm doing this, guys, is because the triangle will cease to work. Okay, for example, this is one of the first formulas that we will use in physics. Got a triangle for that?
No.
I don't think so. Okay? Or if you get to physics 20 and you're doing, let's say this one, where t equals 2 pi times the square root of L over G. Got a triangle for that one? Don't think so. Okay? Here's another formula we're going to use in physics in Science 10. Triangle doesn't work when there's addition and subtraction and more than 3 variables. So you're going to have to learn to manipulate an equation the proper way, which is not stupid triangles. Okay? So, don't ever let me see a triangle anywhere on anything you ever hand into me. I will go completely crazy and take you with me. Okay? Please do not. Okay? You have to stop using a triangle. If you've been using one, I get it. Someone taught you that. It worked and you kept doing it. But it's not going to work in Science 10. It's not going to be good enough. So, here's all you need to know in order to do simple algebra. Guys, and I tell you this because these 3 simple rules got me through university physics. Okay? 3 simple rules. There's a lot more complex manipulations in university physics than there are in Science 10. And these 3 simple rules will get you through. Okay? If I want to move part of this equation, what do I have to do? The opposite operation. That's algebra rule number 1. If I want to move something, do the opposite. Okay? The second rule of algebra is whatever I do to one side, I do to the other. We call it the golden rule of algebra. Okay? The third rule won't apply to the mole equation, but it will apply to any other formulas you use. Move what's not attached to what you're looking for first. Okay? Because that rule doesn't apply yet, I'm not even going to go into it today. We'll deal with it when we get to y equals mx plus b. Okay? All you need to know in order to manipulate this equation successfully is rule number 1 and rule number 2. Okay? If I want to move something, I perform the opposite operation. Whatever I do to one side, I do to the other. So, if I want to get m, little m, by itself, I need to move big M over to the other side. Right now, what am I doing with big M? I'm dividing. So if I want to move it, I do multiplication. Okay, so that means I multiply this side by big M. Big M over big M cancels. Big M goes away. Now rule number 2. What I do to that side, I do to? I just manipulated that equation to solve for little m. All I had to do was multiply both sides by big M, and it was over to the other side, and I'm solving for mass. Okay? Everybody with me so far? That's the only manipulation of that formula you're going to have to do. We're never going to use this formula to solve for big M, because where do we get big M from?
The division.
From the periodic table, right? That's what we learned to calculate. That's molar mass. We calculate that by adding numbers together from the periodic table. We'll never use this formula to solve for it, because we solve for it with that. Okay? So that's the only manipulation of that formula you're ever going to have to do. Okay? Solve for M. Okay? You're either going to be asked to solve for n, which is how it originally set up, or solve for little m, okay, which is just a simple manipulation of that equation. Okay? Just multiplying both sides by big M. All right. Questions on that? There are only 4 ways I can ask you a mole equation problem. Okay? I can ask you to calculate n, number of moles. I can ask you to calculate mass. The other 2 ways, still the same thing. I can ask to calculate mass, but I give you the number of particles instead of mass. Okay? Or I ask you to calculate the mass of a given number of particles. Those are the only 4 ways I can ask a mole equation question. I'm going to go over each of those 4 ways every day for the rest of this unit. So by the time this unit is over, you will have seen me solve each of the 4 ways I can ask an equation. 5 more times. That many. See, I'm not good at math. Okay. All right, 5 more times. Okay, that means you will have seen how to solve the 4 ways to solve a mole equation. Okay, the exact same ways I'm going to ask you to do it on your unit exam. You'll have seen that 5 times. Okay, there should be no reason to not be able to replicate that set of steps on your unit exam. Okay, write this one down. This is the first way I can ask you a mole equation question. Okay, this is also the easiest mole equation question. How many moles of calcium chloride are in 90 grams? Okay, so a question like this would be out of probably 3 marks. Okay, maybe 4 if I was feeling really generous, but probably 3. Okay, the first mark is for writing down your givens. That is, what values did the question tell me? Okay, the first value the question told you was 90 grams. That's little m. Anytime I get something in grams, that's mass. Okay, grams measures mass. Okay, it's asking me to calculate how many moles. The number of moles is n. So that's what I have to calculate. And then it tells me the compound I'm dealing with is calcium chloride, which will help me to calculate the molar mass. So 40.98 plus 35.45. Yeah, I think I did the math right in my head, but I shouldn't do math in my head, but I'm pretty sure that's right. Okay. All right, so I calculated the molar mass of calcium chloride. So this is my calcium. There's 1 calcium. This is my chlorines, 2 of them. Okay, and I simply added them together. So 1 calcium is, no, 40.08, not 98, 40.08. Okay, and then the 2 chlorines, 35.45 each, times 2, for a total of 110.98 grams per mole. Okay, that's 1 mark. Mark for that. Okay, this is the mole equation. Number of moles equals mass divided by molar mass. Do I need to manipulate that equation at all?
No.
Not for this one. I'm looking for number of moles. So all I have to do is plug in my numbers. 90 grams divided by 110.98 grams per mole. You wouldn't necessarily have to put the units in the calculation, but your answer needs to have units. Okay, so 90 divided by 110.98 is 0.80, or no, sorry, 0.811. 0.811 moles. How do I know it's moles?
Because you're finding the number.
Right. First off, that's what n is number of moles. And secondly, from a mathematical perspective, if I divide grams by grams per mole, the grams cancel and I'm left with moles. Okay, that would be my units. Okay, so you'd get 1 mark for your work and 1 mark for your final answer with units. If you don't put units on your answer, it's wrong. It's not half off. It's wrong. Okay? Because I don't know whether it's 0.811 moles, elephants, old ladies with walkers. Okay? It needs units, or I have to guess.
Is that how you want us to manipulate, like when we're doing it?
Yes. If you show me those steps, right? Because each step is worth a mark. Yeah. Go on. It could be out of 4 if I was feeling exceptionally generous about giving you a separate mark for the formula and plugging in the numbers, which I rarely do. Okay? All right, questions on the first way there? Okay, so that's the easiest way because you basically just plug in numbers, right? There's no manipulation or algebra or anything. All right, write this one down. This is the second way I can ask you a mole equation question. I don't know if we'll get through all 4 today, but we'll try. All right, so for this one, first step, writing down our givens. Okay, what is the mass? All right, so we're looking for little n. Okay, of 4.5 moles. What did they just give me there? Number of moles, so they gave me n. Of magnesium bromide. Okay, so big M, magnesium and bromine. This is a 2 plus, that's a 1 minus, so we're looking at that as our formula. Hey, is it important to be able to drop and swap and get formulas right? If you can't, will you get the rest of this question right?
No.
Okay. All right, so for magnesium bromide, 24.31 plus 79.9 times 2. Actually had that, I think, up here, didn't we? No, we didn't. Okay. Okay, so 24.31 plus 79.9 times 2, 184.11. Grams per mole. Okay, so that would be 1 mark. Okay, n equals little m over big M, and I'm trying to solve for little m. Okay, how do I get little m by itself? Right, I perform the opposite operation. Now, I want to leave little m where it is because it's on the top of the equation. Okay, that's where I want it. I just need it to be by itself. So I'm going to move big M over to this side. Right now I'm dividing by big M. Okay, so I need to multiply both sides by big M. Okay, now I've got my formula. So you would get a mark for that, for manipulating the equation. And then you would get a mark for plugging your numbers in correctly. Okay, so you're going to have 184.11 times 4.5 equals n. Okay, so you get a 3rd mark for that, and then you get a 4th mark for your final answer, which is 828.50. And that's in grams because we were calculating mass.
Do you always want us to do like 2 decimal points?
Yes. Okay, we won't talk about significant digits until we get to physics. So for now, good question. How many decimal places? 2. Okay. All right. Questions on how that one works?
No, it's
You sure?
yeah.
I don't mind answering questions. It's kind of my job.
Were we finding the M, like the little M?
Yep.
Okay.
Yeah, we were finding little m. Yes.
Okay.
Okay. So I had n equals little m over big M. I multiplied both sides by big M, which is why it canceled here, and then multiplied this side by big M, because what I do to one side I have to do to the other. Yeah. Sorry, speak up, no, I can't hear you. It does equal little m. Oh, sorry. Oh, yes.
Yeah, that's okay.
That's what you were talking about. Yeah, totally. That one, not the one I wrote originally. Yeah. Okay. Any other questions on that one? All right, we'll probably leave it there for today. I'll go through the other two tomorrow, and then we'll go through a bunch of examples. We'll practice this, work on it here, okay, going forward. Remember, lots of opportunities to come in for help if you're needing it, okay? The quizzes look pretty good this morning, so that's good, okay? Looks like you guys are getting the reaction stuff, which is the bulk of the unit exam, like 2/3 of it probably, okay? So, we'll see you guys tomorrow, and we'll be working on mole equation then.